Alright, so to prepare the sample, the first thing we need to do, of course, make sure that you're wearing gloves as you're handling things. Use tweezers. You know, the instrument is sensitive enough such that the oils on your hands can actually be detected. So make sure that you wear gloves and you keep everything clean as you're preparing, or as clean as you can as you're preparing the sample. So this station essentially is where you will be preparing the DSC sample. There's a DSC press right here. And we have the two types of pans sitting right here, as well as the accessories for the press are in this box. Now, so what you will see is that they're all color coded. The only two colors that we have are blue and black, as you can see here. So black goes with black, blue goes with blue, and you would see that there is one set of pans here. These are the actual pans that it has both colors on them. So these pans work for either pan type, but the lids themselves are actually different. Okay, so be mindful which setup you're actually using. Now, the first setup that I'll describe is the T0 aluminum. That's what it says on the computer, and these are the standard pans. Both pans are made of aluminum, by the way, so if your material can possibly react with aluminum, you would have to supply your own pans. There are different types of pans that can be used in there, but aluminum are the standard ones. So to prepare a T0 aluminum pan, you need this holder, as well as one of these two press types. Now you can see that the first one is very flat, and the second one has sort of a cup shape to it. They're used somewhat differently. The press type one is easiest for if you're doing films, powders, anything that can sort of be relatively flat to the bottom of the pan. Then this works fine. If you have just a chunk of material and it's possibly a bit hard to break down or something like that, as long as it fits in the pan properly and you can try to seal it with this cup type die, that'll sort of help keep that chunk from sort of moving around the pan. It sort of presses around it. Oops. Sort of presses around that chunk such that it sort of keeps it in place. Okay. Of course, the best types are powders, but not everyone has powders to look at, so that's why they have these sort of different alternatives. So this upper piece actually has a magnetic base. It actually goes upside down like this into a hole right in there. So you basically place it up into the hole like that, and it stays by itself with the magnetic base. So you're going to take this holder, and again we are using the black color code, so you want one of these pans. Be careful when you're opening these because they can fly everywhere. And you want to take a clean pan. Alright, and we're going to rest it right here. Close this. Then we're going to take a black lid. Take one of these, rest them right here. So the first number that you're going to need is your empty pan. So it's going to be basically the mass of these two pieces. So we're going to basically go to the scale, make sure it's properly zeroed out. I typically like to put a piece of weighing paper on there just to make sure things are clean. You definitely do not want to get any residue at the bottom or on the outside of the pan at all. So don't assume anything is very clean, because if you pick up any residue, that residue is going to get into the actual instrument, and I already described what happens when things get into the furnace. So make sure to be very clean when you're preparing your samples. Do not neglect anything. So let's zero that out. So now we're basically going to weigh our empty pan and our lid. Okay, around 55.6. This is actually 55.6 milligrams. The scale is in grams. So that's our first pan mass number. All right. So now I'm going to take the pan, I'm going to place it right in the middle. I'm going to place it right in the middle of the chuck, just like that. Okay, it should sit nice and flat. It shouldn't be angled or leaning over or anything like that. It should just sit into that space. Okay, so now it's actually easier because now I can just hold this and do what I would like to do, as opposed to trying to balance the pan on my tweezers and all these other complicated things. So now I would actually then fill, well, not fill, but I would place my sample into the pan. Now, how much sample do I need? Do not try to fill the pan. What I would typically suggest is you go for about 5 milligrams of sample. That's not a lot for certain people. Some people that may be a lot, but 5 milligrams, in my experience, has prevented a lot of the bad things from happening, but also giving you a very solid signal to be read out in your data. So the goal is not to fill the pan up to the brim and then try to press down on it. The goal is to get about 5 milligrams of sample, whatever that means, in here, and then that should give you a pretty nice sample, a pretty nice signal. For polymers, sometimes they can be very fluffy, so 5 milligrams, you may have to sort of poke things in there. That's okay, as long as they're all inside the pan and not all the way around the pan. But if you're doing, for example, inorganic materials that are pretty dense, 5 milligrams is not a lot. You can very easily go over that. That's okay if you go over it, but try not to go to 20 milligrams type of thing. Some people would suggest 20 milligrams. I don't, because the instruments have definitely matured since 20 milligrams was necessary. I've run samples with less than half a milligram before, and gotten data that was just fine. So the instrument does not require large masses at all to be run. So 5 milligrams should be a nice goal for everyone. If you go a little bit over that, again, that's okay, but try not to. Definitely do not come in here with the aim of filling up the pan, because that's not what you want to do. Okay? So once you place your sample in there, you're then going to take the lid exactly like this, not like that, but like this, and best place it right on top and somewhat centered. You no need to push it down, just make sure it's on top of the pan. Okay? Now, once you have that, you are going to slide this right under and into that slot in the press. Okay? And now I'm basically just going to take one finger. There is a preloaded spring in here, so you don't need to add any real human force to this. It already has the force applied. You just have to swing this handle all the way over. Okay? You don't push down, do anything like that. You just swing it over until it touches the other side. I count 1, 2, 3, and then I lift it back over. Okay? Now when you remove this, you would see that the lid is now straight down inside of the pan. Okay? So if your sample was in here, what would have basically happened is that it had pushed all of your sample down to the bottom of the pan and sort of compressed it slightly such that the sample stays in contact with the bottom of the pan. Now, why is that necessary? The two round pieces where the pan and the reference sit, there are actually thermocouples directly below them. So if your sample is not at the bottom of the pan, then there's basically an airspace in between the thermocouple, which is the thing that needs to pick up all of the changes, and the actual sample. Okay, so that can cause temperature lags and inaccuracies in your data analysis. So these standard pans are set up so that it basically pushes everything down to the bottom and keeps it there throughout the experiment. Now, as you can imagine, if you're doing that, then these pans are not good for things like liquids, for example, where you push on them, it's going to squirt back out. So these are only good for solid samples. And by solid samples, I mean dried powders, films, things like that are relatively stable and that do not or cannot sort of squirt out of the pan. These are not sealed in any way to prevent any liquids or gases from coming out. So these pans are only for more stable materials. Okay? And basically this pan now that it's sealed and assumed with your sample inside, your next step is to simply take your tweezers and lift it out and place it back into the scale and remeasure it. Of course, this is going to be basically the same mass because there's nothing in there. But now you would have a different mass, right? Because it would be your pan and your lid plus your sample. Okay? So if you subtract the empty pan and lid from this number, now you have your sample mass. And that's the other number that you need to place into the computer. Okay? So remember that you're subtracting this number from the first number to get your sample mass, not just writing this number into there. Okay? And basically now your sample is ready to go, and you're basically going to take it. I like to keep it in here just so I can carry it easier. And you basically go over to the auto sampler and place this in the correct sample slot. Okay? So this in itself is your T0 aluminum pan, or your standard pan for DSC. Now, like I said, this pan is only good for sort of stable materials, powders, films, things like that. If I want to do liquids, gels, colloidal suspensions, anything that has significant amount of liquid or solvent in them, these are not the pans to use. What you would like to use now is the blue color. So I'll show you how to prepare these types of pans. So we're going to simply replace everything, all the black colors with the blue colors. There are only two. This is the bottom piece, and this piece, just like the other one, it has a magnetic base, and it goes straight into the top of the press. Okay? So now I'm going to use the same bottom pan as a demonstration. Again, the bottom pans take both colors. Okay, now I'm using blue, and I want a blue lid. It says T0 hermetic lid, and these lids are pretty flat, so it's very easy to take up 2 or 3 of them at a time. So be sure that you're actually just picking one up. And so you take one, you can place it right there. Okay, so now I have my pan and my lid, and again I'm going in here, measuring my pan and my lid. In fact, let me take a new pan so I can show you kind of what the mass is going to look like. Let's insert this. So you can see now my pan and my lid, it's around 56, 57 milligrams. Of course, these are going to vary, but you want to make sure that you don't have 65, 70 milligrams, obviously, because you've probably taken more than one lid on there, so you want to try to separate them or take a new one. So again, this is going to be your empty pan mass. Okay, and now, just like I did before, I'm going to take the pan and now it's actually going to sit all the way down into the blue holder like that. So it should be flush with the metal part of this holder, okay? So now, again, just like before, now I'm ready to place my sample in here. You only need a drop. You don't need a lot of the sample. Like I said, 5 milligrams stands for pretty much everything. You know, if you're doing something with water, water's, you know, denser than you think, so a drop can be definitely more than 5 milligrams. So, you know, again, do not try to fill the pan. That's not the intent. The intent is just to have enough material to have a good signal. So you put a drop or maybe 2 of your liquid sample, or a scoop of your gel that maybe you want to test, and place it in here. Of course, be very, very clean. Make sure that the gel, even with the powders and things like that, are not all the way on the outside rim of the sample holder or of the pan, because again, if you don't clean it off, it will get into the DSC. So make sure that you stay clean when you're preparing the sample. And now you add your sample in here. You're going to take the lid, just like before. This time it's simply going to sit right on top of the pan. Okay? It does not push in, it just sits right on top. All you want to make sure is that the lid itself is somewhat centered at the circumference of the pan. That just helps with sealing it better when it goes in there. So now I have my pan, I put my sample in, I have my lid on. Again, make sure the rim is clean before you put the lid on top. And then it goes in here, just like it did before. And again, no force. The difference now is that you feel a little bit of resistance. Just push all the way past. So maybe like right there, but push all the way past it until it hits the other slide. Again, do not apply any extra force. This applies all the force that you need. And back over. And when you remove it, what you should see is a nice ring around the edge of the pan. That means that it's been sealed properly. Okay? If it looks lopsided or weird in any way, it's not sealed properly. Especially if you're doing liquid samples, that's not a good thing. This pan has now been literally crimped, so basically the edge has been folded on itself. Okay? And that actually traps anything that's in this pan in the pan. So now my experiments will mean that, you know, if there's a little bit of evaporation or anything like that happening, it will generally stay inside of the pan, and all of that gas and other bad things won't get into the DSC itself. However, this is only rated for about 2 atmospheres of pressure, which is only about 40 psi, which is really not much. So don't think that, you know, you're going to have something that has 90% water in it and I'm going to push it to 200 degrees. That's not going to happen. You will rupture the pan. In fact, it might rupture before you get to 100. So you're not, if you're doing liquids, if you're doing anything with solvents in them, be very careful of your temperature limits, of where you can go. Know what the boiling point of your solvents are, all these things, and get nowhere close to them, or as best as you can. If you need to, then you need to talk to one of us to make sure that we do the right preparations of your sample and things like that. So that might allow you, and I'm not saying it will, but it might allow you to go closer to that value. But most of the time, we're not going to be going close to the boiling point of your solvent or anywhere like that, because it will rupture the pan. Okay? So this is mainly meant for lower temperature experiments. If you have liquids or gels or things like that in here, you know that your upper temperature is going to be limited. Alright? Now, I have my pan set up. It's sealed up nicely, but it's going to be kind of hard to get my tweezers in here to lift the pan out without bending it. You definitely don't want to bend any of these pans, because remember, the auto sampler has the grip, and so you don't want to cause any issues there either. That's what this little point right here is for. This is actually hollowed at the bottom, so you basically slide it in like that, and it just pops right out. Okay? I typically like to just move it to the side so that I can pick this whole thing back up. And here's my sample pen. Okay? So now, again, I would take this, I would measure it, and that would basically be my new sample mass. Sorry, my sample mass plus my pan mass. And then I would go ahead and do the subtraction to get my sample mass. Okay? And now this sample is ready to go to the auto sampler to get tested. Okay? This is the T0 hermetic pan, or T0 aluminum hermetic pan. And this will actually correspond to reference 2. So if you're preparing any samples that look like this, you're going to be using reference 2. If you're going to be preparing any samples that look like this one, that use the black die set, then you're going to be using reference 1. Okay? So that's how you prepare your samples. Again, be very clean. Make sure that there's nothing on the outside. Definitely nothing at the bottom. No residue, no powder residue, no liquid, anything. Because anything that's on the outside of these pans will then be in the DSC. And it will then be in someone else's sample later on, which is not good. So be very clean when you're coming here to prepare your samples and fill things up. Don't be afraid that after you seal it up, you take a Q-tip or something and sort of wipe around the edges just to make sure that everything is properly cleaned before you place it in the auto sampler. Okay? And basically that's it. Remember to place all of these die sets back into the box. These simply just pull down and remove. Place everything back into the box. Close the box up and leave it right here. Please do not leave anything hanging out around here. These things are expensive. They will cost you a couple $1,000s if you lose them. So make sure they are back in the box. And keep all of the pans and lids right up here. If they are running out, please let us know and we will resupply them. We will fill these boxes back up. For example, the pans right now need some more. So we will go and we will order these. So these are free for you to use. If you need any specialized pans or things like that, that would be for you to purchase. And they will all be yours to use for how many ever times you wish. But the standard configurations, we will pay for them and replenish new ones when we need to. All right, that's the end of the training. If you have any questions, please don't hesitate to ask before you run anything. If you have any odd samples or you're just not sure what your sample is going to do, be sure to come to us and ask us first. Do not rush into running the DSC without any knowledge of what's going to happen. That's not a good thing. A lot of bad things can happen if you don't know what that's about. If you're unsure about the stability of your material, I always suggest running the TGA first. And when I say the stability of your material, I mean your physical material. A lot of people come in with publications saying that their material is stable, but they've never tested the material that they made. So there's always going to be differences between what the publications say and what you make. So always make sure you do those first. Better to be safe than sorry. You would run a TGA and make sure that everything is safe within the temperature range that you care about. Then you can run your DSC. Okay? So always be sure to be safe and understand what your material is going to do before you go in and do the experiment. Alright? And that's the end of the training. And I hope you've learned something, and we'll pick up another time. Finish.